Miscellaneous exercise on chapter 10. Question number 1. Find the values of k for which the line k minus 3 times x minus 4 minus k square y plus k square minus 7k plus 6 equal to 0 is parallel to x-axis. If a line is parallel to x-axis, the line equation will be of the form y is equal to some constant. So, coefficient of x is 0. In this equation, the coefficient of x is k minus 3. So, equate k minus 3 to 0. Therefore, the value of k is 3. Next subdivision, parallel to y-axis. If a line is parallel to y-axis, it will be of the form x is equal to a. That is, coefficient of y should be 0. That is, b should be 0. Here the coefficient of y is minus of 4 minus k square equal to 0. 4 minus k square is 0. Therefore, k square is 4. And k value will be plus or minus 2. C subdivision, passing through the origin. We know that if a line passes through the origin, the constant term should be 0. Here the constant term is k square minus 7k plus 6 equal to 0. Let us factorize this. K minus 1 times k minus 6 is equal to 0. Therefore, k is 1 or k is 6. Second question. Find the values of theta and p if the equation x cos theta plus y sin theta equal to p is the normal form of the line root 3x plus y plus 2 equal to 0. We will change this equation to the normal form. To change the equation to normal form, we have to divide by root of a square plus b square, which is root of a here is root 3 square is 3, plus the coefficient of y is b, which is 1 square is 1, and root 4 is 2. We will divide the equation by 2. We get root 3 divided by 2x plus 1 by 2y equal to minus 2 divided by 2, which is minus 1. In the normal form, p is the length of the normal. Therefore, this has to be a positive quantity. Let us change the sign throughout. Minus root 3 divided by 2x minus half y is equal to plus 1. Now, by comparing these two equations, we can say that cos theta is minus root 3 divided by 2, sin theta is minus half, and p is 1. P should be a positive quantity, and here cos is negative, sin is also negative. Both are negative in the third quadrant. And the base angle, sin 30 degrees is half. Therefore, the third quadrant angle theta will be pi plus the base angle pi by 6, which is 7 pi by 6. Therefore, p is 1 and theta is 7 pi divided by 6. Third question. Find the equations of the lines which cut off intercepts on the axis whose sum and product are 1 and minus 6 respectively. Let the intercepts be A and B. So sum of the intercepts is 1 and product of the intercepts is minus 6. From these two equations we can say that the numbers are 3 and minus 2. Or you may find b from this equation and substitute in the first equation. You will get a quadratic equation in A. Solve for A. You will get two answers for A, 3 and minus 2. But this is easier. Directly we can write the numbers. So we have two answers. If A is 3, B is minus 2. And if A is minus 2, B will be 3. Let us write the equation in intercept form. The intercept form of a line is x by A plus y by B equal to 1. Therefore, the equation is x divided by 3 plus y divided by minus 2 is equal to 1. We will multiply the whole equation by 6. We get 2x minus 3y is equal to 6. Now the second answer is, if A is minus 2, B will be 3. Therefore, using intercept form of a straight line, we get x divided by minus 2 plus y divided by 3 is equal to 1. We will multiply the equation by 6. We get minus 3x plus 2y is equal to 6. Question number 4. What are the points on the y-axis whose distance from the line x divided by 3 plus y divided by 4 equal to 1 is 4 units? We will change this equation to general form. Multiply by 12, we get 4x plus 3y is equal to 12. 4x plus 3y minus 12 equal to 0. And we have to find the distance of this line from a point on the y-axis. So let us take the point as 0, y1. It lies on the y-axis, so x coordinate is 0. And the distance of a line from a point, formula is absolute value of ax1 plus by1 plus c divided by root of a square plus b square. And this distance is given as 4 units. And the numerator is substituting the point in this equation. Absolute value of 4 times 0 plus 3 times y1 minus 12 divided by square root of a square is 4 square, which is 16, b square is 3 square, which is 9. 16 plus 9 is 25, square root of 25 is 5. 4 times 5 is absolute value of 3 y1 minus 12. To remove the absolute value sign, we have to write plus or minus sign on any one side of the equation. Plus or minus 20 is equal to 3 y1 minus 12. Now we have two equations to solve. We will take plus 20 equal to 3 y1 minus 12. Therefore, 3 y1 is 32. y1 is equal to 32 divided by 3. And the second equation is minus 20 is equal to 3 y1 minus 12. Minus 20 plus 12 is minus 8. Therefore, y1 is minus 8 divided by 3. Therefore, the points are 0, y1, 0, 32 by 3 is one answer, and we have another answer which is 0, minus 8 divided by 3. Question number 5. Find the perpendicular distance from the origin to the line joining the points cos theta, sin theta, and cos phi, sin phi. Let us first find the equation of the straight line joining these 2 points using 2-point form. The formula is y minus y1 is equal to y2 minus y1 divided by x2 minus x1 times x minus x1. We will take the first point as x1, y1, second point as x2, y2. Therefore, the equation is y minus sine theta equal to sine phi minus sine theta divided by cos phi minus cos theta times x minus cos theta. We will cross multiply. Cos phi minus cos theta times y minus sin theta cos phi plus sin theta cos theta equal to, the other side is sin phi minus sin theta times x, then minus sin phi cos theta and plus sin theta cos theta. Sin theta cos theta are getting cancelled. Let us take x term to the left hand side, minus of sin phi minus sin theta times x, then y term cos phi minus cos theta times y minus sin theta cos phi plus sin phi cos theta equal to 0. Let us distribute this negative sign and write the first term as sin theta minus sin phi times x plus cos phi minus cos theta times y. This is of the form sin A cos B minus cos A sin B. The formula is sin of A minus B. Therefore, it becomes plus sin of phi minus theta. We have to find the perpendicular distance from the origin to this line, and the formula is absolute value of c divided by root of a square plus b square. Absolute value of c is sin of phi minus theta divided by root of a term is sin theta minus sin phi the whole square and b term is cos phi minus cos theta the whole square. Absolute value of sin of phi minus theta divided by square root of, we will expand this using a minus b the whole square identity, which is sin square theta plus sin square phi minus 2 sin theta sin phi. Similarly, the second term is cos square phi plus cos square theta minus 2 cos phi cos theta. Absolute value of sin of phi minus theta divided by sin square theta plus cos square theta is 1 and sin square phi plus cos square phi is 1. 1 plus 1 is 2. 2 minus 2 times sin theta sin phi plus cos theta cos phi equal to absolute value of sin of phi minus theta divided by root of 2 is common, we get 1 minus, and this is cos A cos B plus sin A sin B, which is cos of A minus B. Cos of, we may write phi minus theta or theta minus phi. The numerator has phi minus theta, so let us write cos of phi minus theta in the denominator. Absolute value of sin of phi minus theta divided by root of 2 times 1 minus cos x formula is 2 sin square x by 2. We get phi minus theta divided by 2. absolute value of sine of phi minus theta divided by 2 times. When we take the square root, we have to give a positive answer. So we will write under absolute value sign. It is sine of phi minus theta divided by 2. We can further simplify this answer. Half into absolute value of the numerator is 2 sine phi minus theta by 2 cos phi minus theta divided by 2 divided by the denominator is sine of phi minus theta divided by 2. 2 also could be cancelled. Therefore, the answer is absolute value of cos of phi minus theta divided by 2. Question 6. Find the equation of the line parallel to y-axis and drawn through the point of intersection of the lines x minus 7y plus 5 equal to 0 and 3x plus y equal to 0. We will first solve these two equations and find the point of intersection. We will multiply the first equation by 3. 3x minus 21 times y plus 15 is 0. And the second equation is 3x plus y equal to 0. Change the sign. These two are getting cancelled. Minus 22y plus 15 is 0. Y value is 15 divided by 22. From the first equation, x minus 7 times y plus 5 is 0. Therefore, x is 105 divided by 22 minus 5. 22 is the LCM. 105 minus 110. The answer is minus 5 divided by 22. Therefore, the point of intersection is minus 5 divided by 22 and 15 divided by 22. And we are going to find the equation of a line parallel to y-axis passing through this point. If a line is parallel to y-axis, the equation will be of the form x is equal to a, where a will be the x coordinate of this point. Therefore, the required equation is x is equal to minus 5 divided by 22. Question 7. Find the equation of a line drawn perpendicular to the line x divided by 4 plus y divided by 6 equal to 1 through the point where it meets the y-axis. We will multiply this equation by 12. 3x plus 2y is equal to 12. We will find the meeting point of this line with the y-axis. So on the y-axis, x coordinate should be 0. Let us substitute x as 0. 2y is 12. Therefore, y coordinate of that point is 6. Therefore, the point where this line meets the y-axis is 0, 6. And we will find slope of this line. Slope of this line is minus a divided by b. A is the coefficient of x, which is 3, and b is the coefficient of y. The line which we have to find is perpendicular to the given line. Therefore, slope of the perpendicular line is, change the sign and write the reciprocal. The formula is m1 m2 is equal to minus 1. Now we know the point through which it passes and we know the slope. We will use point slope form and write the equation of the line. The point slope formula is y minus y0 is equal to m times x minus x0. y minus 6 is equal to 2 divided by 3 times x minus 0. Let us multiply by 3. 3y minus 18 is 2x. Therefore, 2x minus 3y plus 18 is equal to 0. Question 8. Find the area of the triangle formed by the lines y minus x equal to 0, x plus y equal to 0 and x minus k equal to 0. We will solve these equations and find the points of intersection. This is equation number 1, equation number 2 and 3. Solving 1 and 2. Y minus x is 0, x plus y is 0. Minus x and plus x are getting cancelled. 2y is 0. Therefore, y is 0. From the first equation, y is equal to x. Therefore, x coordinate is also 0. Therefore, the first point of intersection is 0, 0. Now we will solve second and the third equations. X plus y is 0, x minus k is 0. We will subtract the equations, change the sign. X minus x are getting cancelled. Y plus k is 0. Therefore, y coordinate is minus k. From the third equation, x coordinate is k. Therefore, the second point of intersection is k minus k. Write the x coordinate first. We will solve first and the third equations. Y minus x is 0. X minus k is 0. Minus x plus x are getting cancelled. Y minus k is 0. Therefore, we get the y coordinate as k. And x coordinate is k from the third equation. Therefore, the third point of intersection is kk. We have to find the area of the triangle formed by these 3 points. And area of the triangle formula is half into absolute value of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. We will take the first point as x1 y1, second point as x2 y2 and the third point as x3 y3. Half into absolute value of x1 is 0, the first term becomes 0. x2 is k. y3 minus y1, y1 is 0, plus x3 times y1 minus y2. Minus of minus k is plus k. Half into absolute value of k square plus k square. The answer is half into 2k square. Because of k square, we can remove the absolute value sign. Therefore, area of the triangle is k square square units. Question 9. Find the value of p so that the 3 lines 3x plus y minus 2 equal to 0, px plus 2y minus 3 equal to 0 and 2x minus y minus 3 equal to 0 may intersect at one point. First equation, second, third. We will solve first and third. We don't have p in those two equations. 3x plus y minus 2 is 0 and 2x minus y minus 3 is 0. We get 5x minus 5 equal to 0. X coordinate is 5 divided by 5, which is 1. We will substitute in the first equation. 3 plus y minus 2 is 0. Y plus 1 is 0. Therefore, y coordinate is minus 1. Therefore, the point of intersection is (1 minus 1). It is given in the question that the given three lines are intersecting at a point. Therefore, the second line also passes through this point. Substituting 1 minus 1 in the second equation, we can find the value of p. P into 1 plus 2 times minus 1 minus 3 is equal to 0. P minus 5 is 0. Therefore, P is 5. Question 10. If three lines whose equations are y equal to m1x plus c1, y equal to m2x plus c2 and y equal to m3x plus c3 are concurrent, then show that m1 times c2 minus c3 plus m2 times c3 minus c1 plus m3 times c1 minus c2 is equal to 0. Concurrent lines means they pass through the same point. These are concurrent lines. We will take the first equation as 1, second and the third. Solving first and second equations, y is equal to m1x plus c1 and the second equation y equal to m2x plus c2. We will change the sign. 0 is equal to m1 minus m2 times x plus c1 minus c2. m1 minus m2 times x is equal to minus of c1 minus c2. Therefore, x is c2 minus c1 divided by m1 minus m2. I distributed this negative sign. This is the x coordinate of the point of intersection. We will substitute this x in the first equation to find the y coordinate. Y is equal to m1 times this x coordinate plus c1. The LCM is m1 minus m2. The numerator is m1 c2 minus m1 c1 plus m1 c1 minus m2 c1. Therefore, the y coordinate is m1 c2 minus m2 c1 upon m1 minus m2. Therefore, the point of intersection is the x coordinate is c2 minus c1 divided by m1 minus m2 and the y coordinate is m1 c2 minus m2 c1 divided by m1 minus m2. Since the lines are concurrent, the third line also passes through this point. Substituting in the third equation. The third equation is y is equal to m3x plus c3. Y coordinate is m1 c2 minus m2 c1 divided by m1 minus m2. m3 times the x coordinate is c2 minus c1 divided by m1 minus m2 plus c3. On the right hand side, we will take LCM m1 minus m2. The numerator is m3c2 minus m3c1 plus m1c3 minus m2c3. We will cancel the denominators. We will write all the terms on the left hand side. m1c2 minus m2c1 minus m3c2 plus m3c1 minus m1c3 plus m2c3 equal to 0. We have m1 in this term and in this term. m1 times c2 minus c3. Then we will collect m2 terms plus m2 times c3 minus c1 and then m3 terms plus m3 times c1 minus c2 equal to 0, and this is the result to be proved. Question 11. Find the equation of the lines through the point 3, 2 which makes an angle 45 degrees with the line x minus 2y equal to 3. We will find the slope of this line, which is minus a divided by b minus 1 divided by minus 2, half. And we will take the slope of the line which we have to find as m2. An angle between the lines is given. We will use tan theta formula. Tan theta is absolute value of m2 minus m1 divided by 1 plus m1 m2. Tan 45 degrees is 1, which is equal to m2 minus m1 divided by 1 plus m1 m2. 1 is equal to, we will take LCM, 2m2 minus 1 divided by 2 plus m2. LCMs will get cancelled. Now to remove the absolute value sign, we will write plus or minus on the left hand side. 2m2 minus 1 divided by 2 plus m2. We have two equations to solve. The first one is 1 is equal to 2m2 minus 1 divided by 2 plus m2. Cross multiply. Therefore, we get m2 is equal to 3. We will solve the second equation with minus sign. Minus 1 is equal to 2m2 minus 1 divided by 2 plus m2. Minus 2 minus m2 is 2m2 minus 1. 3m2 is minus 2 plus 1, which is minus 1. Therefore, m2 is minus 1 over 3. We have two answers for m2. Now, the first answer is the line passes through the point 3, 2 and slope is 3. We will use point slope form. Y minus y0 is m times x minus x0. Y minus 2 is 3 times x minus 3. Y minus 2 is 3x minus 9. Therefore, the equation is 3x minus y equal to 7. So, the first answer is 3x minus y equal to 7. We will write the second answer. It passes through the point 3, 2, but the slope is minus 1 divided by 3. We will use point slope form. Y minus 2 is equal to minus 1 by 3 times x minus 3 multiply by 3 minus x plus 3. Therefore, the equation is x plus 3y equal to 9. This is the second answer. Question 12. Find the equation of the line passing through the point of intersection of the lines 4x plus 7y minus 3 equal to 0 and 2x minus 3y plus 1 equal to 0 that has equal intercepts on the axis. We will first solve them and find the point of intersection. Multiply the second equation by 2. 4x minus 6y plus 2 equal to 0. We will change the sign. These two are getting cancelled. 7 plus 6 is 13y minus 5 is 0. Therefore, y coordinate is 5 divided by 13. Let us substitute in the second equation. 2x minus 3 times y plus 1 is 0. 2x is 15 over 13 minus 1. 13 is the LCM. 15 minus 13 is 2. Therefore, x is 1 divided by 13. We will write the point of intersection. One divided by 13, 5 divided by 13. The line passes through this point and the line has equal intercepts. That is, A is equal to B. We will use intercept form of the straight line. X divided by A plus y divided by B is equal to 1. A and B are equal. We will multiply the equation by A. We will substitute 1 divided by 13, 5 divided by 13 in this equation because the line passes through this point. 1 divided by 13 plus 5 divided by 13 is A. Therefore, A value is 6 divided by 13. Therefore, the equation of the straight line is x plus y is equal to A. We can write the answer as 13x plus 13y is equal to 6. Question number 13. Show that the equation of the line passing through the origin and making an angle theta with the line y is equal to mx plus c is y by x equal to m plus or minus tan theta divided by 1 minus plus m tan theta. Let the equation of the line be y is equal to m1x plus c. It passes through the origin, therefore, c will be 0. Therefore, the equation becomes y is equal to m1x. The slope of the line is m1 and slope of this given line is m. An angle between these two lines is theta. We will use tan theta formula. Tan theta is absolute value of m2 minus m1 divided by 1 plus m1 m2 equal to absolute value of m1 minus m divided by 1 plus m1 m. We will remove the absolute value sign by writing plus or minus sign on the left hand side. We will cross multiply plus or minus tan theta plus or minus tan theta times m1 m is equal to m1 minus m. We have to find m1. Let us take this term to the right hand side. So, it becomes minus plus m1 tan theta. And on the left hand side, we have plus or minus tan theta, and we will take this minus m term to the left hand side, it becomes plus m. m1 is common here, we get 1 minus plus m tan theta equal to m plus or minus tan theta. from which we can find m1, which is m plus or minus tan theta divided by 1 minus plus m tan theta. We know the slope of the line. We will substitute m1 in this line equation. From this equation, y divided by x is m1. Therefore, equation of the line is y divided by x is equal to m1 answer, which is m plus or minus tan theta divided by 1 minus plus m tan theta. Question number 14. In what ratio the line joining -1 1 and 5 7 is divided by the line x plus y equal to 4? Let this point be -1 1 and this point be 5 7. This line x plus y equals 4 divides this line segment in the ratio k is to 1, say. Let the ratio be k is to 1. We will use section formula. The formula is mx2 plus nx1 divided by m plus n, and the y coordinate is my2 plus ny1 divided by m plus n. Therefore, we get 5k minus 1 divided by k plus 1, and the y coordinate is 7k plus 1 divided by k plus 1. The ratio is k is to 1. Like cross multiplication you have to do. And this point lies on x plus y equal to 4. So, this point should satisfy this line equation. We will substitute the coordinates for x and y. 5k minus 1 divided by k plus 1 plus the y coordinate is 7k plus 1 divided by k plus 1 is equal to 4. We will take LCM k plus 1. 5k minus 1 plus 7k plus 1 is equal to 4. 12k is equal to 4k plus 4. 8k is 4. Therefore, k is half. Therefore, the ratio is half is to 1, which is 1 is to 2. Question 15. Find the distance of the line 4x plus 7y plus 5 equal to 0 from the point 1 2 along the line 2x minus y equal to 0. Let this line be 4x plus 7y plus 5 equal to 0, and the second line be 2x minus y equal to 0. And this point 1 2 lies on this line. Substitute and check. 2 minus 2 is 0. 1 comma 2 lies on this line. We have to find the distance of the first line from this point measured along this line. We will name this point as P, this as Q. We need the distance PQ. We will solve these two equations and find the point Q. We will take this as equation 1, this as equation 2. We will multiply the second equation by 2. 4x minus 2y is equal to 0. We will change the sign. These two are getting cancelled. 9y plus 5 is equal to 0. Therefore, y is minus 5 over 9. Now, let us find the x coordinate. I am using the second equation. 2x is equal to y, which is minus 5 divided by 9. Therefore, x coordinate is minus 5 divided by 18. Therefore, the point of intersection Q is minus 5 divided by 18 minus 5 divided by 9. Now we will find the distance PQ using distance formula. Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Square root of P point is 1, 2. 1 minus of minus will become plus 5 by 18 the whole square plus 2 minus of minus plus 5 by 9 the whole square. Square root of 18 plus 5, 23 divided by 18 square plus 18 plus 5 is 23 divided by 9 the whole square. Square root of 23 square divided by 9 square is common. We get 1 divided by 2 square plus 1. 23 by 9 square root of 1 by 4 plus 1. 23 divided by 9 times square root of 5 divided by 4. This is 23 divided by 9 times root 5 divided by 2. Therefore, the answer is 23 root 5 divided by 18 units. Question 16. Find the direction in which a straight line must be drawn through the point minus 1, 2 so that its point of intersection with the line x plus y equal to 4 may be at a distance of 3 units from this point. Let this be the line x plus y equal to 4. A line is drawn through the point minus 1, 2 so that its point of intersection with this line may be at a distance of 3 units. Let this be P, this be Q. PQ distance is 3 units. That is, we have to find the slope of PQ. For that, first we will find the point Q. Let Q point be x1, y1. Q lies on x plus y equal to 4. Therefore, x1 plus y1 is equal to 4. We have one equation in x1 and y1. We need one more equation. We will use this distance 3 units. PQ is equal to 3. Therefore, root of using distance formula x1 minus of minus 1 the whole square plus y1 minus 2 the whole square is 3. Squaring both sides, we will substitute for y1 from the first equation. Y1 from the first equation is 4 minus x1. We get x1 plus 1 the whole square plus 4 minus x1 minus 2 the whole square is 9. And this becomes 2 minus x1 the whole square. We will simplify this equation. Let us expand. This is 4 plus x1 square minus 4x1 minus 9 equal to 0. We get a quadratic equation in x1. 2x1 square minus 2x1, 5 minus 9 is minus 4. We will divide the equation by 2 and let us factorize. X1 minus 2 times x1 plus 1 is equal to 0. We get two answers for x1. x1 is equal to 2 and x1 is equal to minus 1. If x1 is 2, y1 is 4 minus 2, which is 2. If x1 is minus 1, y1 is 4 minus of minus 1 plus 1, which is 5. So we got 2 points. 2, 2 is one answer, minus 1, 5 is the other answer. We have to find the direction of the line. First answer, we will find the slope of line joining minus 1, 2 and 2, 2. So slope is equal to y2 minus y1 divided by x2 minus x1. 2 minus 2 is 0 divided by 2 minus of minus 1 plus 1, 3. The answer is 0. The slope is 0. Therefore, the line is parallel to x-axis. Now, the second answer, we will find the slope joining the given point minus 1, 2 and the answer which we got. Slope is equal to y2 minus y1 divided by x2 minus x1. Here the denominator is 0. The slope is not defined. Therefore, the line is parallel to y-axis. Therefore, the line is parallel to x-axis or parallel to y-axis.